Imagine you're trying to read a book, but your brain can only hold the last 3 pages in working memory. Everything before that becomes increasingly fuzzy. That's basically what's been happening to AI language models for the past 3 years. They hit a wall where adding more data or longer context windows doesn't just cost a bit more compute, it costs exponentially more. A startup just claimed they've broken that wall, and the benchmarks. They are showing inference speeds that shouldn't be possible with current hardware. Here's the thing, if this is real, it doesn't just mean faster chatbots. It means models that can reason through complex problems, handle massive datasets in one go, and run on consumer hardware instead of requiring data center clusters. The artificial intelligence industry has been waiting for someone to solve this, and now somebody says they have. Let's dig into what the bottleneck actually is, why every lab from OpenAI to Anthropic got stuck on it, and how this startup's approach is different from everything tried before. To understand the breakthrough, you need to know what broke in the first place. Language models work by looking at every word in your prompt and computing how much attention each word should pay to every other word. It sounds simple, but the maths is brutal. If you double your context length, the amount of text a model can consider at once, you quadruple the computation needed. Go from 4,000 tokens to 8,000 tokens, and suddenly your training costs go through the roof. This is why for years, most models topped out at roughly 4,000 tokens of context. Some pushed to 8,000. A few ambitious teams got to 100,000, but each step up required redesigning everything. The transformer architecture, the underlying blueprint that powers ChatGPT, Claude, and every modern LLM was built when context windows were measured in hundreds of tokens, not hundreds of thousands. So researchers kept hitting the same problem. To make models work with longer contexts, you either had to accept slower inference, meaning responses take 10 times longer, or you had to spend absurd amounts on computing power. Neither option was acceptable for real-world deployment. Here's where it gets technical, but stick with me, because this is the core of the puzzle. At the heart of every language model is something called the attention mechanism. It's how the model figures out which words matter most when predicting the next word. You ask the model what's the capital of France, and it needs to focus on capital, France, and ignore filler words like the and of. But here's the catch. To compute attention, the model has to compare every token against every other token. 1,000 tokens, that's 1,000,000 comparisons. 100,000 tokens, that's 10 billion comparisons. The memory required grows with the square of the context length. Double your context, and your memory needs quadruple. By 96,000 tokens, you're using more memory than exists on most graphics processing units. That's the wall. Researchers have been trying workarounds for years: sparse attention, local attention, chunking the problem into pieces. But every workaround either compromises the model's ability to reason across long distances or adds complexity that slows things down. This startup claims they've found a fundamentally different approach, one that doesn't scale with the square of the context length at all. So what does this bottleneck mean if you're actually using an AI model? Let's say you're a lawyer wanting Claude to analyze a 100-page contract against precedents, all that context at once. Right now you can't. You have to chunk the document, run it through the model multiple times, and stitch the answers together. You lose the coherence. A researcher wants to run a language model over a year's worth of scientific papers to spot patterns nobody's noticed. Again, can't do it in one pass. You're stuck running separate queries and praying the model catches the connections. An AI startup wants to build a real-time transcription service that improves as it listens, learning from context as a conversation unfolds. Current models can't hold enough context to do that properly. These aren't theoretical problems. They're the reason AI assistants still feel fragmented. They forget context, miss nuance, and require you to re-explain things. Every limitation people complain about traces back to this bottleneck. If a startup has really cracked it, these limitations just vanish. Long documents, one shot. Complex reasoning, the model sees everything at once. Real-time learning from context, finally possible. Every major lab has thrown researchers at this problem. Google's got dozens of people on it. Meta's invested in sparse attention variants. Anthropic's researching constitutional approaches to handle longer sequences more intelligently. So what does this startup claim to have that nobody else does? The crucial difference. Instead of trying to make attention work at scale, they're claiming to have replaced the problematic mechanism entirely, or at least reimagined how it operates. Rather than comparing every token to every other token, they are using a mathematical structure that captures long-range dependencies without the quadratic scaling. Think of it like the difference between checking every person in a city against every other person to find people who know each other versus using social network maps to find connections instantly. It's a different problem entirely. The startup showed early benchmarks showing similar accuracy to standard models, but with dramatically faster inference on long sequences. That's the claim, anyway. Whether it holds up under real-world conditions, whether it works on novel domains, how it performs on actual downstream tasks, whether the training cost is actually lower, that's what the industry is now rushing to test independently. This breakthrough, if validated, doesn't just solve an old problem, it arrives at a pivotal moment for the industry. AI companies are facing massive infrastructure costs. Training costs are doubling every 6 months. The compute required to run the latest models is stretching even the biggest budgets. An efficiency breakthrough that cuts training time or enables smaller hardware to do bigger jobs, that's worth billions of dollars. But there's more. Longevity and reasoning require context. Models that can hold and process enormous amounts of information are closer to genuine artificial general intelligence, systems that don't just pattern match, but actually reason. Right now, even the most capable models are limited by how much context they can hold simultaneously. Remove that constraint, and you suddenly enable capabilities that seemed impossible. Real-time learning, multi-day reasoning tasks. The ability to hold an entire knowledge base in working memory, these change from fantasy to engineering problem. The implications ripple outward fast. If this works, within 18 months, you'll see open-source models that run on consumer hardware with capabilities that currently require data center access. That changes who has power in AI development. It democratizes it. And that's why every major lab is now scrambling to independently verify whether this claim is legitimate. So how do we actually determine if this breakthrough is real? First comes independent verification. Papers get published, other labs run the benchmarks themselves, and the results either replicate or they don't. That process typically takes 2 to 4 months. Simultaneously, the startup has to show it works beyond toy problems, real applications, real datasets, real-world latency. If it holds up, funding follows immediately. We are talking Series B rounds measured in hundreds of millions. Within 6 months, the first integrated versions appear in open-source frameworks. Within a year, major labs license the technology or develop their own variant. The second phase is scaling. Does this approach work when you train a model from scratch, not just fine-tune existing ones? Does it work across different architectures and domains? Here's what to watch for. Publications from the startup showing reproducible results, response from OpenAI or Google acknowledging the breakthrough, and open-source projects implementing their method. If all three happen within 6 months, it's probably real. If the startup stays quiet or the independent verification fails, it probably wasn't. Here's what this means for you, whether you're using AI tools or just watching how the field evolves. If this works, the AI tools you interact with are about to get noticeably smarter and faster. Chatbots will understand context better. Research assistants will handle longer documents without losing the plot. Real-time applications become feasible. But there's a bigger picture. Breakthroughs like this determine who leads the AI industry for the next 5 years. The startup that solved the bottleneck has leverage. Open-source communities that adopt the method gain years of development advantage. Researchers who understand this approach become incredibly valuable, and the entire frontier of what's possible with large language models changes forward by a significant margin. This isn't just an incremental improvement, it's the kind of architectural breakthrough that only comes around every few years, whether it's real or oversold. Watch how the independent verification unfolds over the next few months. The answer you get will tell you a lot about where artificial intelligence is heading. Want to stay ahead of these breakthroughs? Follow for daily AI news and let me know in the comments what LLM capability you'd unlock first if context windows were suddenly unlimited. We read everything.